specimen of saturated clay with a thickness of 19 millimeters reaches 50% consolidation in 20 minutes. The question asks for the time that takes for a 5 meter layer of the same clay in the same condition to reach the same degree of consolidation, which is 50%. And in the second part, it's asking for the time that it takes for the soil to reach 30% consolidation. So we know the degree of consolidation is a function of TV, and TV is equal to CV times T divided by D on the power of 2. So if CV is constant, we'll have this relation between T and D, and in this case, since this specimen is under an odometer test, and in the odometer test the sample's drainage condition is open layer, so D1 would be 90 divided by 2, and it says that it's in the same stress and drainage condition, so D2 would be half of the clay layer thickness, so it's 5,000 divided by 2, which is 2,500. This was 9.5 millimeters. So for U50, they have T2 equal to T1 multiplied by D2 over D1 the power of 2, which is equal to 20 minutes times 2,500 divided by 9.5 the power of 2, and then we're going to multiply this to this value to convert the time into years instead of minutes, and our T2 would be equal to 2 and 63 years. This is the answer of the first part of the question. So it takes almost 2.5 years to the 5 meter layer of that same clay to reach 50%. Now we want to know how long does it take for the clay layer to reach 30% consolidation. So we know for U less than 60%, the equation for TV in U is pi over 4 and U in the power of 2. This is equation 4.23 of Craig's soil mechanics. Also, we know that TV is CV T over D in the power of 2. So we know the same layer of the clays being used. So CV is the same and D is also the same. So it's a 5 meter thick clay layer. So using these two equations, we will have T2 over T1 is equal to U2 over U1 in the power of 2. So T of 30% is T of 50% times 30% in the power of 2, 50% in the power of 2,